Hello my dear beauty champions, welcome back to our channel Diksha Karnataka. Today I am here to finish your unit calculus with the chapter Differential Equation. First of all, let me know how are you all doing, how are the sessions in Masterstroke helping you in your preparation in the comment section. So I hope the class session is very much clear. I am here to deal with the last chapter in your calculus unit, which is Differential Equation. Again, we can pinpoint here also that what topics we should study and from where the questions will come. So whether it is LDE, whether it is variable separable method, we'll see all of that, don't worry about it. Whether the MCQ side of the chapter, so we'll see all of that. We'll cover up everything which is there in the chapter in one shot. This is again a concept session, so still my thinking is in mathematics the best way to learn a problem or learn a concept is with the help of a problem. Okay, so I'm gonna take questions on individual topics and we'll learn all of these. Okay, now before I start, do not forget to hit the subscribe button, because if you are here, if you are learning with me, I make sure that every class there is a value addition, every class there is a small progress, and we get closer to our dream of getting into the top colleges of Karnataka, right? So if you don't want to miss out on that, do not forget to hit the subscribe button and keep the notification bell always on. And for the class notes, for the PDF of this class, simply join the WhatsApp community. Link is given. If you already joined it, good for us. Otherwise, join right away and get all the PDFs completely for free. Okay, so now I think now we can start, sir. We can start the class. Okay, now before I start, I am here to give you a gift. I think many of you have already downloaded it, many of you already availed this gift. But what is this? So we are here, we are Diksha Karnataka, we are giving you all 4 free mock tests. One for physics, one for chemistry, one for maths, one for biology. So PCMB is there, each one you're gonna get. So for PCMB you get one test for free, exactly free. There's no hidden charges, there's nothing like that. You have to get this free, nothing like that. For free you get. And for that, what you have to simply do, go ahead, check in the link given in this video. You'll find a link like this. For example, in this lecture of integrals, you'll find the link given over here, free KCET PCMB mock test PDF. Simply click on the link, visit, you'll get this kind of pop-up. Once this pop-up is there, once the screen is visible to you, fill your details and simply mobile number and OTP, and later you move on to the PDF, where you get access to PDF with the questions as well as the answer for KCET. Okay, is that clear? Yeah. Moving on, so now let's understand the chapter itself, which is differential equation. Very simple chapter, very simple chapter, and very straightforward questions also. For example, in PU2, what question comes, sir? So 1 or 2 question comes in your MCQ or 1 marker, where it is about order and degree, or it is about your number of constants in whether a particular solution is concerned or general solution is concerned. Yeah, that is the kind of question that comes in PU2 side. No problem, sir. What about in subjective questions, sir? That is 1 marker clear. Subjective questions, a 5 marker will come in your linear differential equation category, and there can be a small question on variable separable method also. Okay, so we'll see all of that. Right now, let's understand what is a differential equation. So it is a mathematical equation, of course. It is a mathematical equation which relates a function and derivative in polynomial form. So I'll repeat, a differential equation is a mathematical equation which relates a function and its derivative in polynomial form. Basically a square, we can have we can have first derivative, second derivative. Basically we can go like this: y2 square minus xy1 equal to 0. What is this, sir? This second derivative x. What is this y1? First derivative. We know how to write it, no? I can write derivative as y1 or dy by dx or simply y dash. My choice of writing it. Okay, usually we write the equation in the form of this only, but just we can represent it in the form of y dash also, or even y1. So is it clear what are differential equations? Clear, right? It's a mathematical equation which creates a relation between the function and its derivative in the polynomial form. Now, as it has the word equation in it, it will have order and degree. Polynomial is there means order and degree will be there, sir. Okay, sir. So order is nothing but your highest value or highest order of the derivative. Check here. So if I wrote in the previous question, check here, it was y square, means I have the maximum of second derivative present. Second derivative is present in the given equation. Okay, it means the order of this equation will be simply beta 2. So the order will be 2. What about degree, sir? The power, the index of this highest order becomes your degree. Degree is also 2. What is the power? 2. For example, if I change the equation, right here y2 minus xy1 square equal to 0. Change it. y2 minus xy1 square. Now if I ask you to write order and degree, so order will change. Will the order change? No. Order represents the highest order of derivative, so remains 2. What about degree? Degree will go to this 2, sir? No. It will be same on the highest order of derivative. Check the index. In this case, what is that index? The power 1. Degree will be 1. Degree is always from where? From the highest order derivative form. Whatever is the power of that term, that gives your degree. And if you have, very important learning, if you have in the equation derivative is in the form of some other function. What's the meaning of that, sir? It is not polynomial function. It can be trigonometric function, it can be logarithmic function, it can be exponential function. If you have these all situations, example, let's say if I have y2 minus x e power y1, what it means? Exponential function is involved in the derivative. When that happens, this will be a differential equation with degree undefined. Degree does not exist. Is it clear? For degree to exist, we should have the derivative in the form of only polynomials. Only polynomials. If you have the derivative in the form of any other function than polynomial, whether trigonometric, logarithmic, okay, inverse trigonometric, or even exponential, the given equation will not have its degree. Order will be there, but degree will not be existing in nature. Is it clear, guys? Both of them here, they are mentioned in the knowledge hub. You can go through it, you can learn it. Simply download the PDF and get the access to all of that. But I hope I have made clear what is the meaning of order and degree, because this will exactly result in 1 marks in your PU2 for Saturn. For KCET, it might, because sometimes if the paper is easy, they can give you a question on that and they can ask you. Otherwise, they can ask a complicated question on integrating factor or on LDE or an HDE. They can keep asking that. Okay, we'll go ahead and learn. Now, if this is the equation, means it will have solutions. If there is an equation, it will have solution. Solution is of two types. Type 1 is called as general. Type 2 is called as particular solution. So this part beta is this is called as equation in both the cases. This is my equation. Now I want to go from equation to the solution. I want to go from the equation to the solution. In this case, what we do is we integrate. To reach the solution from the given equation, for the given equation, we integrate in this case. Okay, so when you are integrating, do you remember something called as, in the case of indefinite integrals, we have something called as arbitrary constant or constant of integration. The other name of the same thing is the constant of integration. Okay, sir. So the constant of integration that you find over here, in this case, can you identify that? Yes, we have A and B. So if the unknowns or if the arbitrary constant are still present in the given solution of differential equation, this is my differential equation. This represents your solution of the differential equation. Okay, so in the solution, if we still can find the arbitrary constant present or the constant of integration present, then that type of solution is called as general solution. I'll repeat myself. If in the solution of differential equation you can still find the constant, the arbitrary constant, then the given equation, so the given solution is still called as general solution. If you move on and see, these unknowns are not there anymore. It is known now. The values are fixed, 3 and 2. They are not unknown anymore. They are a fixed value, 3 and 2. Once we reach this point, how we reach, that is a different story. Don't worry, I have taken an example. I'll show you how we reach from A to 3. That's okay. I will give you the answer for that. We use boundary conditions, we use coordinates. That is okay. But if you reach a constant value 3 and 2, then this type of solution is called as particular solution. Then this is called as particular solution. Difference is clear? When you solve an equation or in differential equation, okay, then you integrate to solve it, and since it is integration of indefinite kind, you will end up with what? You will end up with constant. If the constant is unknown, means if the a, b, c value are unknown, then what happens? Then it is called as general solution. If you are some way able to find or determine the value of these a, b, c, then this equation becomes particular solution. Sir, why are you repeating the same thing? I'm telling you, it's important. We feel it is easy, but it's important. Okay, now a very important reminder and recall for all of you. I hope you already have come across this. This is our latest launch of our course, KCET-30 batch. KCET-30 batch. It comes with surprises and support for all of you to achieve a great rank in KCET. Yeah, so this comes at a price of 2499, but don't worry, the offerings are completely justifiable. We'll show that. Yeah, so it comes with 30 days live online crash course. Once your boards are over, this KCET-30 batch will start. Okay, you can take the enrollment right away, but once the boards are over, your 30-day live crash course will start. Okay, then what else is there, sir? It has KCET previous year question PYQs in solution format will be given. You will get, of course, you will get concept. You'll also get the PYQ solutions for all the chapters. You'll get complete syllabus revision even for PU1. You are all writing PU2 boards, so you all PU2 boards will be well prepared. But what about PU1? Everybody messes up PU1 because they're not serious. Only few are serious. Don't worry, we'll cover up your PU1 syllabus as well. Okay, and even the PYQs of PU1 is also going to be completed. Okay, we'll have chapter wise KCET PYQ in test format. Now you can go at any place and ask. Okay, none of the platforms are having this, that KCET PYQs, PYPs are available as test. Okay, so we are the ones who started with this for the first, and it's extremely successful. Everybody is loving it, because what we have done is, for the last 10 years PYQs of KCET, we are offering you as a actual live test format. Okay, part of the KCET-30 batch for KCET examination, of course. Okay, and you get, apart from all of this, you also get 10 full length KCET mock test. 10 full length means full syllabus KCET mock test. Okay, the course will start from 21st March, which is just after your boards are over, and time, as you can see, 8 AM to 7 PM. Okay, now this is not it. Why this is important? It's not like we have not taught you all on our channel for free. We are supporting you with the free education. Have we not? Yes. And why it is important? What is the offering apart from this? The main thing is a structured fixed schedule which you all have to stick to beta after your exams. What happens is you plan for so many things, but after 2 days, after 1 day, it gets distracted, you lose your confidence, you lose your motivation, and things just fall through. Right? So you have to, more than motivation, you need discipline, and this course gives you just that. Think about the engagement that you have. Okay, you'll have classes, you'll have video lectures, you'll have live classes, you'll have doubt classes, you'll have tests, you'll have PYQs, you'll have so many things to do, and it'll be all planned. This is something which is parents' favorite. They love to see their student, their child, engaged throughout and not waste time, not get distracted, have a proper planning done by your teachers, your mentors, which can actually be fruitful to achieve the result that you are all dreaming of or have planned for yourself. Okay, so please take this right now. Acha, this price beta of 2499 is only valid till 25th Feb. After that, the prices will go up for sure. If you're thinking that, sir, you say this always, but you don't increase the price, I'm telling you, we don't increase because we keep we keep requesting our team to let it be. Let's not increase it because students cannot afford it. Okay, but still, this time it actually will go up after 25th February. So if you are somebody who is looking to actually get disciplined learning, proper planning and so many offerings at one place, KCET 30 batch is the way to go. Take this crash course right now to make sure that your preparation is on track for KCET examination. Otherwise, the exam has its own expectations. You'll fall through and you'll be somewhere in the poorer rank side and you'll miss your chance to get a good college. Okay, so please make sure that you have taken this KCET 30 batch. Done. Now the question time. As I always say, learnings in maths is incomplete without practice. Question is there, let's learn from here. A very simple question which shows you application of differential equation in the question. So that this is a solution of the given DE. Okay sir, simply take this, as I said, equation, solution. To go from equation to solution, we have to integrate. To go from solution to equation, we have to differentiate. Yes or no? This is solution. I want to go to equation. This is what? Solution, right? Cx plus a by c is a solution. I want to go to equation. What am I going to do? Differentiate. Do that. Now c value is coming as. Now to check whether it is for the same or not, simply replace this value of dy by dx by c. You'll get the result. Check. Yes or no? Makes sense? Yes or no? Yes sir. Moving on. First is done. Next question. Find the differential equation whose solution are given in the following question. We are looking for, we have c plus, my bad, I can write here c equals to 4, 1 second here, I can write this as plus only, c plus 4yx we have equal to 0. I want to go from a solution to the equation, right? This is solution, check here, I want to reach to the equation. How, what are you going to do? Differentiate. Differentiate now, it will be 0, a constant, 4 is common, differentiate by, you'll get dy by dx, x as it is, plus y as it is, derivative of x will be 1. Okay, move this 4 on that side, will be simply 0. You write this as x y1 plus y is 0. Because dy by dx is y1. X y1 plus y. Does it make sense or not? A simple question. Sir, will the question like this come? It might. Okay, they are simple question, but they are on the learnings, the basics of differential equation. Now we also have some questions where you actually have to go opposite. This is from where to where? These questions, both the questions are from solutions to equation. Usually the question comes from here to here. They'll give you equations, you have to find the solution. Let's go and check that out. That is coming under methods of solving first order, first degree differential equation. Yes, in our syllabus we have that only. We don't have second order, we don't have second degree solutions. Okay, so we have to only deal with first order and first degree differential equations. So in that we have few methods. Method number 1, the most popular one, is what? Variable separable method. Number 2 is what? Rarely used but it is still important, HDE, homogeneous differential equation. And 3 will be the most common one and usually coming in examination is LDE, linear differential equations. Okay, again usually what happens in HDE, after substitution we go back and use the same method of variable separable, but this is a different method altogether. HDE is also solved using the variable separable approach, but LDE has a different method altogether. Let's try and solve this question first with using variable separable method, but you have to use some substitution over here because we have x plus y. Take x plus y as v. Now differentiate. 1 plus dy by dx is dv by dx. Correct? No? Correct, right? Now we have to find this value. You can check over here. So we get here dy by dx equals to dv by dx minus 1. Moving this 1 on that side. Now transform this equation. You get here v square dv by dx minus 1 equal to 1. Correct? I have used substitution of dy by dx as this and v as x plus y. Now check. Move this v square over there. So you'll get v square. Sorry. 1 second. I'll use this space also. It'll be useful. That's why. Okay, so I'll move this v square over here. I'll get dv by dx minus 1 equals to 1 upon v square. Now move on that side. We get dv by dx equals to 1 upon v square plus 1, which becomes what? 1 plus v square by v square. Now check. What is this becoming? I can separate the variables over here. I can write one of the type variable at one side, other type on the other side. So I get here v square upon 1 plus v square dv, and this side we have dx. Now we have separated the variables. Now we go back to the next step, which is what? Integrating both sides. Integrating both. I told you this, from equations to solution we have to integrate. Okay, so to integrate this, what we're gonna do? Substitution? No, actually we can use a smart method of adding 1 and removing 1. So v square plus 1 minus 1 divided by v square plus 1, this with dv, and this is with again integration of dx. Check this out. I can separate on this term. I get this and this will be cancelled. If I separate with the bracket, I'll get integration of 1 minus 1 upon v square plus 1 dv plus integration of dx. Let me explain this last step again if you have confusion. I've added 1 and minus 1, okay, because I have same in the denominator. Now I have separated this with the bracket, so this and this will cancel, so I have only 1 left, and this will be 1 upon the same denominator. Now this is simple integration. Integration of dv with 1 will be what? v. And what about this term? This will become minus tan inverse of v equals to x plus c. Please check. Right? This is nothing but 1 upon 1 plus v square means 1 upon x square, that is tan inverse of x. In this case, tan inverse of v. Put back the value of the variable that you used in the beginning. It was what? X plus y. So right here, x plus y minus tan inverse of x plus y and x plus c. Check here, x and x cancels. I can take on that side. So I get here y equals to tan inverse of x plus y plus c. X plus y plus c. Have a look. Because the negative of tan inverse can come on the other side like this, and y remains over there. Y equal to tan inverse of x plus y plus c. Now if I have to ask you what type of solution is this, if I call this to be question number, let's say 3, please comment type of solution. Comment type of solution. We have 2 solutions, right? General and particular. Tell me what type of solution is this in the comment section right now. Let me know in the comment section. Okay, if I talked about question number 3 right here, question number 3, this is the solution, sir. Let me know the type. Okay, sir. Next is homogeneous differential equation. I'm gonna give you steps how to solve it. So again, these are the equations which has net degree to be 0 or same. Okay, means equal sides, equal degrees. Check here. If I talk about this condition, you take v as, check here, y by x. If I take v as y by x, the degree of both will be what? Always equal. Okay, so they are of the kind homogeneous differential equation. What I do in this, simply if this is my equation, dy by dx is f of x comma y. Okay, at every term degree should be same. When that is there, I simply substitute y as vx or v as y by x and differentiate. Check here, if you have y as vx, differentiate, you'll get dy by dx as v, because differentiating x will give me 1, and x times of dv by dx. So change this to this. change dy by dx to v plus x dv by dx, and then what is the next step? Variable separable method. After this, the same thing what we did in the first question. Variable separable method, use that to get the result. Okay, this method, variable separable method. Got it? Clear? So this is how you solve it, and the final answer, replace the value of v by y by x. Let's look at this question. Same approach. Take here. Okay. Sorry. So again, same thing. Y by x is v. It means y value is vx. Differentiate, you'll get dy by dx as v plus x dv upon dx. Okay. Come on, let's write over here equation. This value will be represented by this, so v plus x dv upon dx minus y by x is minus v from here, and this becomes cosec y by x means cosec v. Cosec v equals to 0. Do not worry about this right now, because this is given to find what? This is the coordinate given, or the boundaries are given to find us the final result as particular solution. Okay, next what? Check v and v is cancelled. Now I can move this over there. Am I right? Yeah. So I get x dv upon dx equals to minus cosec v. Correct? Minus cosec v. Did I miss something? dy by dx is v plus x dv by dx. That is nothing but minus v. Cancels. Yeah, correct. Now separate the terms. What are we going to use? Variable separable approach. Let's do that. We'll have here dv by cosec v. Okay, comes over here, and dx by x comes over there. Dx by x comes over there. Okay, so if you check this out, you can integrate over here with the minus sign. You can integrate over here with the minus sign. What is going to be? Very simple, sir. 1 by cosec is what? Sine. Okay, or I can do one thing. Sine v is there with dv, and we have dx by x, right? So I'll move this minus sign to on this side, because integration of sine is what? Minus cosec. It will become simply plus cosec. Okay, sorry, minus cos. It will become plus cos v, and equals to on this side ln x. This much you know, this much basics you know, ln x plus c. This thing is called as general solution. General solution. Now next step is to find what? Is the question over? Not yet. We have to switch back the values in terms of v2, x and y. Let's do that. We'll get here cos of y by x equal to ln x plus c. This is again what? Your general solution in terms of original variables y and x. Now we're going to move on to find the final answer, which is x is 1 and y is 0. Use that to find the value of unknown, which is c, and put it back. So cos of 0 upon 1, which will be 0. Ln of 1 will be 0 plus c. Okay, plus c. So I get the value of c as 1, I guess, right? Cos 0 is 1. 1 second. Cosec will become sine. Sine integration is cos. Yeah. No. Sine cos integration is sine. Sine integration is minus cos. That becomes plus cos only. Did I miss something? C is coming as 1. It should come as minus 1. It's coming as 1. Okay. Let me just cross check one more time. That is right. This is right. Okay. Please check the sign and let me know in the comment section. But for me, C is coming as 1. If C is coming as 1, my final answer becomes what? Check here. This becomes cos of y by x equals to ln x plus 1. ln x plus 1. ln x plus 1. Have a look. Let me know if this is coming as minus 1 for all of you. I'll cross check also, but I think this is the right answer. I'll check. Okay, let's call this to be question number 4. For question number 4, just check once. Answer is this. This is called as particular solution, and this question is from where? Homogeneous differential equation. Moving on. Now the last and very important concept, high weightage in everywhere. Okay, whether it is KCET or PU2, question will come from here. So steps involved to form the linear differential equation. Before we start with the steps, let's understand the type of equations. We have two types. One of the type is called as this is the first type, type 1, where y is dependent variable. I'll repeat, or x is independent, and y is dependent. When you have this, you get px and qx, means some function of x over here and some function of x over there. Okay, then this is used to find the integrating factor. Okay, now this is one of the form. So when you're looking to find integrating factor, okay, let me give you the steps over here itself. Okay, so you're gonna go like this: e power integration of px dx. You'll get this answer and integrating factor. Once you obtain this particular value, your final answer is given by y times of integrating factor equals to integration of integrating factor into qx dx. This is the final answer or steps involved. First thing is, whatever the equation given to you, whatever the differential equation given to you, write in this form if it is where x is independent, this form is making. Then from here obtain the value of px and qx very clearly, means functions in the terms of variable x. Once you have obtained that, use px to find the integrating factor if. Sometime question is asked directly in the exam as find the if. Okay, so this is very crucial. Very crucial. Integrating factor is very crucial. if means integrating factor. Once that is there, the final answer is given by y into if, integration of if times qx dx. Don't worry, I'm going to give you a question on this to help you understand better. Next one is, when y is independent, then you have p of y over here times of x and q of y. Same approach where y is independent variable and your integrating factor is e power py dy, and your answer is given by x times of integrating factor, okay, equals to integration of integrating factor qy dy. So check here, it all depends upon which is the independent variable, okay. Based upon that we have two forms. Let's look at one of the question. Now tell me, over here we can see that is of the form dy by dx. It is means y is dependent and x is independent. Right now this is what we see, but let me simplify and obtain what is making sense. Of course I'll transform this over there. So I'll get what, beta? I'll get x minus e power tan inverse of y dy by dx equals to minus 1 plus y square. Okay, sir. But good thing is this is in terms of y square only, but over here we have mix of both. So basically this will be making more sense if I bring on this side, if I bring this thing over here and this thing over there. Correct? No, because we're gonna get separation of y terms together and x terms together. Sorry, x and y terms together, because check here, in both of the cases we have always one side with only variable of one kind, so q of y or q of x. So if you separate over here this and this term together, I'll show you. X minus e power tan inverse of y, okay, divided by minus of 1 plus y square if you take, and bring on this side, it will become dx by dy. Check, this term over here is becoming q of y actually. I'll show you. Expand, you'll get minus x upon 1 plus y square, and this is becoming what? Minus and minus, so plus e power tan inverse of y. Excuse me, I know it might be confusing for some of you, but don't worry, I'm going to simplify for all of you. Tan inverse of y and 1 plus y square becomes dx plus dy. Let me write one last step pakka and you'll get it. Okay, so check here. I have separated this over this minus sign. This becomes minus, this becomes minus and minus, so plus. Okay, now make this term shift on that side. So we have e power tan inverse of y 1 plus y square equals to dx upon dy minus, what do we have? Okay, plus, this minus becomes plus, so x upon 1 plus y square. I know this term should be on the left, no actually, because in the standard form we have dx plus dy on the left hand side. So let me write that just to make things easy for us. So I'll just switch back this equation. I'll get here dx upon dy plus, I'll write 1 upon 1 plus y square, and I write here into x equals to e power tan inverse of y upon 1 plus y square. Now if you compare, you'll get the value of p and q very clearly from here. Check py is going to be simply check here, this value. This is your py and this is what? Qy. Because we had the form when y is independent as py into x and qy. Py into x and qy. Now this is the form where y is independent and x is dependent. Now tell me, does it make sense or not? Yes sir, it made sense. So first step was to get my equation in the standard form where x or y is independent. We got that. Now it's solving. So what is the first step to solve it? Integrating factor. So e power this function py means 1 upon 1 plus y square and of course dy. So e power, what is this equation? Tan inverse. So e power tan inverse of y. This is the value of integrating factor. Solution is given as, if you remember, x times of integrating factor means e power tan inverse of y, this side, equals to, check here, integration of e power tan inverse, the integrating factor times q. Q is again same thing, e power tan inverse of y upon 1 plus y square dy. 1 plus y square dy. Okay, let me simplify one more time. X e power tan inverse of y. Over here we have e power 2 tan inverse of y, because we have the same thing, divided by 1 plus y square dy. Now of course this is not a difficult question, right? Because we can see that clearly over here. This is making a case of substitution in integration on the right hand side. So what are you gonna do? Take beta tan inverse of y as t, differentiate now, get 1 plus y square dy as dt. Check. So you'll have over here e power 2t and dt, because dy by this will become simply dt. Right or not? Yes sir. So x times of e power, don't change on this side, okay? Let it be, doesn't matter. We are just solving the integration right now. Usually we can solve the right hand side and then put it back together, but let's check. We'll have e power 2t dt, because we have taken tan inverse as t. So e power 2t dt, right sir? So answer becomes simply integration of this will be e power 2t by 2 and plus c. We have x e power tan inverse of y, 2t means, put it back, x e power tan inverse of y e times of 2 tan inverse of y upon 2 plus c. Okay, if you want you can divide it, but it doesn't matter. If you want you can divide, no, it will become what? This will cancel with one of them. You will have e power tan inverse by 2 and c times of e power minus tan inverse. If you want, take this as the answer, because they have not given anything to find the value of c, or you can write this as x equals to e power tan inverse of y upon 2 plus c times of e power minus tan inverse of y. Your choice. If I divide this e power tan inverse on both sides, no, you'll cancel one of them over here and you'll have minus sign with the exponent. Make sense? So your choice, this or this. This is your answer for LDE. It's a very good question where you have to actually transform this given equation to get the form of y as independent variable, the standard form of that. Once that is obtained, you find the integrating factor. this is important step. Second important step is this, the writing this particular step as the standard solution, getting this part, and next step will be to use the substitution and the result. Make sense? Have a look one more time. Yes, so this is the end of your lecture in differential equation. Even though it was very precise, but tell me, was it covering everything or not? Yes, so this is the end of your calculus unit. Now of course we have other chapters in PU2, we'll cover that. Okay, let me know how was the session in the comment section. For now, this is it. I'll see you again very soon. Till then, take care. Bye bye.